Okay, so first we're going to start off with making our graph. We're going to start off with the left side of 1 because that's where our restriction's at. So we have the left side of 1, so we're going to input 0. So we're going to have negative 0 plus 2, absolute value, plus 3, which is going to equal negative 2 plus 3, which is going to put us at 1. So, and then we're going to do the same from here until we notice pattern, so we can draw our graph. So we're going to put negative 1, and if we put that in the absolute value, we're going to get 1, negative 1 plus 3. That's going to put us at 2. And then negative 2, 0, that's going to put us at 3. And then negative 3, that's going to put us at negative 1, which is going to put us at absolute value of negative 1, which equals 1, but then that's going to turn into a negative. So it's negative 1 plus 3. So we're going to go back down to 2. And then because it's an absolute value, it really shouldn't go back up. So we can also start drawing our graph. And then as we can see, the rate of change for this one is negative 1. So we're just going to go down by 1. And that's the left side. Now for the right side, we have x greater than 1. We have negative square root of x minus 1. So we're going to input 2. So we have 2 minus 1, square root of 1, 1. So it's just going to equal 1. No, negative 1, my bad. Oh, my back. Okay. Okay, so we're going to start off with 3. So we have 3 minus 1, 2, square root of 2. Or square root of 2 is not a whole number. So we're going to skip that one. And we're going to go to 4. So we have 4 minus 1, 3, square root of 3. That one also does not exist. So we're going to go to 5. We have 5 minus 1, which is going to be 4. So square root of 4 equals 2, negative 2. And then we're going to go to 6. That's going to give you a 5. 7, that's going to give you a 6. 8, that's going to give you a 7. 9, that's going to give you an 8. And 10, and so forth. So since those aren't whole values, we can just make our graph from here. So it's going to be, sorry, that line sucks. Oops. Let me draw a better line. No, it's almost the same. And you also got to remember that there are no restrictions other than 1, which we haven't been given. So it's going to be continuous on both ends. And then we have 1. So since these are both less than or greater than 1, and we don't have something that's equal to 1, we're going to see how they approach from both sides. So we're going to input 1 into this one. So we're going to get 1 plus 2, which is 3. And then negative 3 plus 3, which is going to be 0. So this is going to approach 0. And then we're going to input 1 for this one, which is 1 minus 1, which is also going to equal 0. So then we also have 0. So it approaches 0. But because we do not have a point for 1, this is going to be an open point because it is not defined. Now with that graph, we are going to move on to the next part, which is evaluating limit of f of x as x approaches 1 from the left. And we're going to go to 1 from the left. As you can see, it's just going to be approaching 0. And then f of x for 1 approaching from the right, that is also going to be approaching 0. So, and then we have just a value, so we already figured it out. From the left it's approaching 0, from the right it's approaching 0, so that means the limit exists. So this would equal 0. And we're going to answer the question, does the function have discontinuities? And the answer is going to be yes. And that is because this right here, that open point, that's not any better, but that open point is going to be our discontinuity that we're going to label. And the type of discontinuity that is going to be is it's going to be a removable hole, because as you can see, there is no value defined to it, but the limit still exists. So it's going to be yes, the function has a removable hole at x equals 1. And that is going to be the answer and how to find